Hello all. In this session we can solve some problems in activity. The first question is find the activity of 1 milligram of radon given half-life as 3.8 days. And we know the formula for activity, it is dN by dt is equal to lambda n. The question is to find activity, that is we have to find dN by dt. So we should know what is lambda and n. Here t half is given as 3.8 days and we know the relation between t half and lambda as lambda is equal to 0.6931 divided by t half. So lambda will be 0.6931 divided by t half is 3.8 days. So here we have to take t half in SI unit, that is seconds. So 3.8 days should be converted into second. So 1 day you know it is 24 hours and 1 hour you know 60 minutes and 1 minute it is 60 seconds. So 3.8 days are converted into seconds and substituting this we get 2.11 into 10 raised to minus 6 and the unit will be second inverse. So lambda is found out. Next we have to find capital N and the question is find the activity of 1 milligram of radon. So from Avogadro hypothesis we know one atomic weight of an element in gram contains 6.023 into 10 raised to 23 atoms. If we are taking the atomic weight in kilogram, then the number of atoms will be 6.023 into 10 raised to 26. So here the question was about radon and its atomic weight is radon atomic weight 222 gram. So what we can write, 222 gram of radon contains 6.023 into 10 raised to 23 atoms. Here we are taking in grams, so the number of atoms will be in 6.023 into 10 raised to 23. So the question is to find the activity of 1 milligram of radon. So 222 gram contains this Avogadro number of atoms. So what is the number of atoms in 1 gram? So 6.023 into 10 raised to 23 divided by 222 will give the number of atoms in 1 gram of radon. Our question was to find the activity of 1 milligram. 1 milligram in terms of gram it is 10 raised to minus 3 gram. So number of atoms in 1 milligram or 10 raised to minus 3 gram will be 6.023 into 10 raised to 23 divided by 222 into 10 raised to minus 3. Substituting we get it, the number of atoms as 2.71 into 10 raised to 18. So in order to find the number of atoms, we have to find the number of atoms in 1 gram and for that you have to divide the Avogadro number by atomic weight. So now the activity will be dN by dt is equal to lambda n and lambda we got as lambda is equal to 2.11 into 10 raised to minus 6 and n we got as 2.71 into 10 raised to 18. So multiplying we get it as 5.69 into 10 raised to 12. 10 raised to 12 disintegrations per second. Second question, calculate the weight of 1 Rutherford of radium with atomic weight 226 and half-life 1620 years. So from the formula we know dN by dt is lambda n And dN by dt is the activity. It is given as 1 Rutherford. Converting into SI unit, we get as 10 raised to 6 disintegration per second. Next, we have to find lambda. Lambda, you know, 0.6931 by T half. And T half is given as 1620 years. So, lambda will be 0.6931 divided by 1620. It is given in years, so we have to convert this into seconds. So 1 year, you know, it contains 365 days, and each day is having 24 hours, and each hour 60 minutes, and each minute 60 seconds. So substituting this, we get 1.957 into 10 raised to minus 11, and unit will be second inverse. So we got lambda. So we know dN by dt, and we now got lambda also. So n will be, what is the formula for n? N will be dN by dt divided by lambda. So substituting, we get the number of atoms is 5.11 into 10 raised to 16 atoms. So the question was to find the weight in, So we have to find the weight of this much number of atoms. And from Avogadro hypothesis, we know one atomic weight contains 6.023 into 10 raised to 23 atoms, or 6.023 into 10 raised to 23 atoms. Weight of 6.023 into 10 raised to 23 atoms is 1 atomic weight. So here the atomic weight is 226. So the weight of one atom will be 226 divided by 6.023 into 10 raised to 23. So the weight of 5.11 into 10 raised to 16 atoms will be weight of one atom into number of atoms. So substituting, we get 1.917 into 10 raised to minus 5 gram. Third question is 0.5 gram of a radioactive element disintegrate at the rate of 1 curie. Calculate its half-life and mean life. Atomic weight of the element is given as 226. Here also the formula dN by dt is equal to lambda n, and dN by dt activity is given as 1 curie, which is equal to 3.7 into 10 raised to 10 disintegration per second in terms of SI unit. And so dN by dt is there, and we have to find half-life and mean life. So only by knowing lambda we will find half-life and mean life, and n we have to find. So again, from Avogadro hypothesis, we know 226 gram of the substance contain 6.023 into 10 raised to 23 atoms. So from this, number of atoms in 1 gram will be Avogadro number divided by atomic weight. So the number of atoms in question, it is given as 0.5 gram. So number of atoms in 0.5 gram of the radioactive substance will be number of atoms in 1 gram into mass. That is 0.5, 6.023 into 10 raised to 23 by 226 into 0.5. And substituting, we get the number of atoms as 1.332 into 10 raised to 21. And from the activity law, we know dN by dt is lambda n. So n we have found out. So lambda will be dN by dt divided by n. So dN by dt is 1 curie, that is 3.7 into 10 raised to 10. divided by number of atoms we found as 1.332 into 10 raised to 21. So substituting, we get lambda as 2.77 into 10 raised to minus 11 per second. So now it is easy to find mean life and half-life. So half-life, that is T half, is equal to 0.6931 divided by lambda. So substituting, we get 0.6931 by 2.77 into 10 raised to minus 11, that is 2.502 into 10 raised to 10 second. So the half-life is obtained in seconds. We can convert this into years. So to convert seconds into years, we know we have to divide it by 365 into 24 into 60 into 60. So this much seconds in years we get as 793 years. Next we can find mean life. Mean life T bar is equal to 1 by lambda. So just taking the reciprocal of lambda, lambda is, we know, 2.77 into 10 raised to minus 11. So taking reciprocal of lambda, we get as 3.61 into 10 raised to 10 seconds. So converting into years, that is this 3.61 into 10 raised to 10 divided by 365 into 24 into 60 into 60, we get as 1144.7 years. So thank you all.